All right. You got paper, Nelson? Okay. So let's begin. Today, guys, we're doing the same thing that we did yesterday, but we're doing it with a new log, or 2 days ago, a new log called the natural log. So I'm going to share with you guys what that is. And that's, so it's actually, no, that's a common log, but so what we're doing today isn't new, it's completely old, but it's going to look different, so that's why we have to spend some time on it. It looks weird, but you're actually doing the same thing that we've been doing. So let's go ahead and chat a little bit here. So part A, let's get our definition down. What is the natural log? Okay. Okay, guys, this is my time, so please be quiet. Still talking? Okay, so last chapter we learned about a special base called E, Euler's number. Okay? Why is it a special number? Well, it has something to do with how real-life phenomena, how they really grow, and they grow continuously if they're growing exponentially. And so it's the natural language of exponential growth. And we saw, and I also mentioned that in calculus it works really nicely. It turns out like you get, when you're working with exponential functions, that one always gives you really nice clean answers. Everything else gives you a mess that you don't want to deal with. So it was exponential functions looked like this. Well, this is an exponential function, right? So we can write that as a log. If I were to write that as a log, it would be log, what's my base? E, and what's my argument going to be now? Y. Equals x, right? Now, you could write it like that, and that's fine, and maybe today it would help you to write it like that, but that's not how they write it. This thing, I'll be right with you, Javier. They decided that this thing was so useful and so special that it should get its own little name. We're not supposed to write this? Yeah, you're writing this. They decided this little log here is so useful and special that it should get its own little name. And so instead of writing log base E, here's how they write it. They just put ln.
Why do your arrows look like that?
So it's ln. So when you guys see ln, you're going to have to translate that. It's log base E. Okay, so that's the problem. I'm going to be giving you guys some problems today, and you're going to not realize that, oh, those are the properties we learned yesterday, like this one, for instance, right? Log base 10 of 10. What does that equal? 1, right? Well, if you see this, that equals 1. The reason for that is because this is log base E, isn't it? So you could think of there being a little base E there. They match. The answer is different. It got pushed or something. So that's what a natural log is. All right, so Javier, you got a question? All right, so is anybody still writing this? Okay, I'll pause for a sec. Let's move forward here. So first thing that we're going to do, example 1. Example 1. We're going to do the same stuff we did before, so I'm going to give you an exponential expression here, like e to the second power equals something. Give me a second here. Got a bonus point question here for you guys. I was just about ready to offer that as a point. Yeah. Yes. All right. 7.389. We don't need to do all those. Let's just do 7.4. We don't need to get that crazy. Let's do 7.4. Okay, so I want to write this as a log, right? Now, you can write this middle step if you want to, but I would kind of like you guys to get to the point where you don't have to. So I'm going to write 2 steps for this. The middle step, I would like you guys to get to the point where you don't have to do that, but it might be helpful at first. So to change it to a log, we're going to, I'll draw a different arrow for you there, John. We're going to put log, and what kind of a base do we have here? E. And what's going to go next to that?
7.4.
And it equals what? 2. Okay, now, but when it's log base E, we don't write it like that. What do I replace log base E with? So I would like you guys just to be able to go straight to this if you could. But if you need to do the middle step, I'm okay with that. Okay? You guys think you can handle one if I threw one at you? Let's try it.
Right.
What
No
is that
nothing,
throw?
Jesse, no nothing. You gotta hand it to us.
Let me hand this one off to you here. So student practice 1. See if you guys can rewrite this as a logarithmic expression. Go ahead. I'll give you a second. Now, when I made these questions, I had to start with this, though. I don't know if you guys remember how to do this on the calculator, but if you want to figure out how to do this again, you just push second, and then you push your LN button, right? And that gives you the E. And then inside the parentheses, you're going to type a half or 0.5, whatever you prefer. And that should give you 1.6 something, right? Now, the reason why it's not exactly right is because when I wrote this down, I didn't put 1.648721271. I just rounded it to the tenths. So that one was a little close, but it wasn't exactly right, right? So we're rounding. There it is. All right. So we're going to be messing around with this type of log stuff today. Let's do the opposite, though. Let's do example 2. We're going to do the opposite now. I'm going to give you a log expression. And how about you guys help me out with this? Do ln of 8 on your calculators. What are you guys getting there?
2.07.
So I'm just going to round it to 2.1, okay? Now what I want you guys to do is I'll demonstrate it. We're going to write this thing in exponential form. So in other words, we're doing the exact opposite of what we just did in the last example. I want to write this thing in exponential form. I'll wait for you guys to finish writing that, and then I'll do it. So I'll give you a second. Close. We got to flip and shift the 2.
Oh, yeah.
All right. Good. All right. So once again, I'm going to do 2 steps here, but I'd rather if you don't have to do the middle step, that's good. So here's the middle step. The middle step is I want you guys to realize this is really just a log with a base of E. It's kind of helpful to see that there when you want to change it into exponential form. So if I want to change this to exponential form, what do I write first? E, and then what's my power going to be? The one that's over here, right? 2.1, and equals the other number there, right? And we could check this on our calculator too. You guys should be able to do e to the 2.1 power. It's not going to be exactly 8, but it should be really close to 8. Okay? So I'm going to let you guys try one here. ln of, I don't know, 0.6? 26. ln of 26 is 3.3. So go ahead and see if you guys can write that as an exponential function real quick, and then I'll call on you to share out your answer. And, just for the heck of it, if you get a chance, try to do those things on the calculator too. Try the, once you get the exponential function, try to punch it in your calculator and see if you can get it to work. Yeah, close though, right?
27.1.
Yeah, if I were to have gone more decimals, it would have worked better. Logs and exponential functions are very sensitive, so even if you're off by sometimes 1,000, it can make a difference in the outcome. Probably, right? Well, just I would keep it as 26 because I had.
Oh, whoopsies.
You probably heard Sam.
No,
All right. Let's see here, John. What'd you get, bud? Not sure. Okay. How's about Kendall? What'd you get, Mayor?
E to the 3.3 equals 26.
Very good. And you could check that in your calculator. And Samantha tells us it's like 27. That's not horribly close. It's off, and that's because this is rounded. Logs and exponential functions are both very sensitive. So when you round, the more decimals you give, the better, because you'll get closer. But we'll leave it at that. So that's the first part of our lesson. So now I want to move into the properties and what those look like. So part B. Properties with ln. Uh-huh.
You could have done 3.28.
Yeah, it would have been better. Yeah, that would have been more precise. Yeah, the more numbers you give after the decimal, the better it'll be. All right. So, you don't need to write. I'm going to write two sides, a left side and a right side. You don't need to write the left side. That's just for me to explain things. The right side is what you want. But if you want to write both, you can. So one of our properties we learned 2 days ago was this property here. What did that equal? That was 0. Anytime your argument is 1, the answer for a log will be 0. Well, the same thing applies to ln. If you have a 1 there, the answer is 0 still. Because e to the 0 power, like any other number, equals 1. All right? What did we learn about this? That was 1. Well, what that looks like in logs is this. Well, natural logs. Because this has a base of e. So just like over here, the base matches the argument, so you get 1. We have a base of e matching the argument, so it's 1. It just looks different. It's supposed to be equal in height. Yeah, because it's not a subscript. They call it a subscript, like when you have a little number or a letter at the corner. So this is not a subscript. Usually, now this is a subscript, but with ln, we don't write the subscript. It's like the common log. We don't write the subscript for that either. All right. So what's another one we learned? We also learned this. We learned that if log base a of a to the x, what did that equal? That just equaled the exponent, right? These things kind of like canceled each other out. Same thing applies here. If you have ln of e, so long as these match, right? In this case, they match again. The answer will just be the x. So you can think of this as like ln is canceling the e. All right. We learned another one. We learned this guy. A to the power of log with a base of a, and the argument of that log is x. The base here and the log with base a cancel each other out and leave me with x, right? What do you guys think this one would look like? Just x, right? Is x. So if it's e to the ln of something, the answer will always be that something because the e and the ln cancel each other out. And ln has the same properties as log in that you can't ever have, you don't need to write this one, but you can't have this. That's undefined. So if you ever push that on your calculator, it'll say error. You can't have ln of a negative number either. That's not possible. Just like with regular logs, they have to be positive numbers only. Okay? So those are our properties, and we're just going to look at a couple problems that involve using the properties with that stuff now. And then it'll probably be a quick day. We'll probably finish a little early. We'll see. Because what time is it? 2:08? We'll probably finish early. Can I proceed?
Yeah.
All right, we're on example 3 here. Here we go. So, I'm just going to write a couple problems up here.
Why did your L's just completely conform?
I know, I'm not consistent about that. So I do this, I do this, I do this. I just change my mind all the time. I don't know why, I'm sorry. But they all mean LN, I'm sorry. I'm not consistent. What does it look like on the calculator? Is it 2 capitals? I don't know what the proper way to do it is, honestly.
No, it's
Your capital.
no, mine are
Sorry about.
capital.
You guys can be consistent though if you want.
Mine are what's that one? Lowercase. Wait, what's the heading for this? I know.
Example 3.
That's all.
Oh, like what are the directions? I didn't write my directions. We're basically just going to simplify or evaluate. You could say. Uh-huh.
For number 3, I put that in, and it says domain error.
Yeah, that's right. We'll get to that. Yeah.
No, we just changed that.
So that's no solution.
Yeah.
Exactly. I'll make it a little bit easier.
Oh, are you?
A little bit. No, I'm gonna make mine hard. I'm gonna make your guys a little bit easier. So this is just teacher example. So I'll wait a little longer in case you guys are still writing this, and then we're gonna put our solutions. Oh, nah, not quite. All right, here we go. So what does this equal, guys?
0.
Right? That's just that first property we wrote down on the last page. Anytime you got a 1 there, the answer is 0. How about this one?
5.
That's right. These kind of like just cancel each other out when you have that setup. You're left with 5.
And that's no solution.
This one is no solution, and it's because it's a domain error is what your calculator says. Oh, sorry. No solution. Why is there no solution? Because
Negative.
the argument has to be positive. You can't have 0 and you can't have negative, right? This one, what's this one?
6.
Yeah, because this and this cancel. It's kind of like this one.
I'm guessing the
And
last
now
one
we go
is
to
yours.
5 where it looks like a nightmare.
Yeah, so number 5 is a hard one. So let me break it down for you a little bit. Although I bet somebody in here knows the answer. Can somebody tell me what anybody think they know it?
1/3.
What do you think, Chris? You're close.
3.
No,
Negative 3. 1.
I can't tell what you're saying.
1/3.
No, it's not 1/3. It's close though. You're close. All right, so
1/4.
let me help you guys out a little bit. First of all, you guys know that instead of the cube root of e, we can write that as e to the 1/3, right? That's what a cube root is. It's a 1/3 power. So there's a 1 right here, and this is your bottom number. This is your top, right? So we just write it like that. But we also don't like this 1 over the e to the 1/3 power,
So
right?
then it's gonna be what's that called? It's gonna be like point. No, negative. Isn't it negative?
Right? Yeah, so when we don't like it on the bottom, we make it normal with a negative, right? Now what's the answer? Negative 1/3. Huh? You did? Nice job. I didn't hear it, sorry. So that one's a toughie because you had to do 2 things. You had to change your root into a power, and then we had to get it out of the denominator by changing it to a negative. And then you can use the property, okay? So just throwing a couple various problems at you. Can I change slides for your student practice?
Yeah.
All right. No? Okay. I'll wait a little. Fusion, if I did, I could change it to. Whoa, that's interesting. Moved it. I could change it to just basic ln if you like. Put that in parentheses. All right. So show me what you guys got. There's your homework.
That's it.
That's it.